All right, thank you. All right. Electrons and drawing atoms. All right, so there's two basic rules when we draw these atoms, and all I really care about mostly is the electrons. So we're going to write in the protons and neutrons, but it's the electrons I'm concerned with. All right, number one. There are 7 rows in the periodic table.
Wow.
All right, 7 rows on the periodic table. So that means horizontal, right? First row, second row, third row, fourth, fifth, sixth, seventh, down to here. These two actually go in here at the bottom 2 rows. So there's 7 rows, 1 through 7. Okay. Atoms of elements.
Is this like number 2?
This is part of the problem. Atoms of elements in row 1 have 1 electron shell. Sorry about that. Only 2 things you care about today. How many electron shells and how many electrons in each shell. In row 2, they have 2 shells. In row 3, they have 3 shells. In row 4, they have 4 electron shells, so on and so forth. I'm just going to write etc. You get the idea. In case you couldn't see my other periodic table. The first row, right, is just hydrogen, helium. Second row is lithium, beryllium, boron across the neon. Third row is sodium. All the way down. This is row 7. And as you can see, these 2 at the other book, in the book, they put these 2 at the bottom. These go in row 6 and 7.
What is the older 2?
Well, the high number elements like 112, 113, 114, you don't find them in nature. Anything over 92 is not found in nature, so it was made in the laboratory. So something that high, basically they took a couple atoms, they smashed them together, and like 114, it'll probably exist for like 100th of a second. You take a couple readings, write it down, and put it on the periodic table. It doesn't matter, you're never going to use number 114. It's never going to exist long enough to actually use it in chemistry, but it's on there. Probably because 113 is odd, it's less stable than 114. So it's probably couldn't, although some periodic tables have it. But none of those over 110 really matter. You don't ever have to use those or know about them. All right, so that's how many shells there are. What's up? What's so funny? You laughing at school. All right.
What's that?
First element in a row has 1 electron in its outer shell. Second has 2. Third has 3, etc., etc. You get the idea. Okay, so I wrote these rules down. I'm going to draw them for you so this will make sense, because right now you probably think, well, yeah, what's this guy talking about? Let's start with hydrogen. Okay. So hydrogen is atomic number 1. It's the first element on the periodic table. First, I'm going to draw the nucleus. Hydrogen has 1 proton, no neutrons. So in the center, I'm going to draw a little circle or a plus inside of it. That'll represent my proton. And then the question is, how many electrons and how many shells? Well, it's the first row, so it has 1 electron shell. and it's the first element in that row, so it gets 1 electron. So I'm just going to draw 1 electron, and then this shell is like a circular path that the electron takes around the atom. This is the Bohr model, right? That's what I'm using. They don't always go in circles, but we're drawing in circles. That's it. That's hydrogen. 1 electron circling 1 proton. Let's do helium next. That's about right next. So, if we look at the nucleus of helium, should be, well, it's atomic number 2, so there should be 2 protons, right? 2 protons. The atomic mass is 4, so there's got to be 2 other things in there. Those would be neutrons, right? Okay. Now, how many electron shells? 1, because it's in the first row, right? Hydrogen and helium are the first row on the periodic table. We each have 1 electron shell. How many electrons? 2, because it's the second element in that row. So 1 electron and another one. I like to put them on opposite sides because electrons repel each other, so they're probably going to be far away from each other. And that's it. Let's do lithium.
Oh, we have to do this on the test?
Yes, I will say draw an atom of magnesium, and you'll do that. Lithium. So first, let me do the nucleus. I'm not going to draw the protons and the neutrons because that's too much space. I'm just going to write 3 protons, put P plus for a proton, and lithium's mass is about 7, so about 4 neutrons usually. Yes, that's the nucleus. How many electron shells is it going to have? 2, because it's in row 2. So what we do is the first shell, the one we're done with, just stays the way it was in the last one. So it has its 2 electrons. That first shell is done. Okay. And then it's the first element in the second row, so the second shell gets 1 electron. So every time we start a new row, we start a new electron shell and put 1 electron in it. So that's
The shell is like a circle.
yeah, the shell is a circle. It's the path that the electron takes around the atom. It's just like if you draw a line for the Earth going around the sun. The line is just imaginary. So anytime you see lithium, sodium, potassium, everything in group 1 on the periodic table, we're always starting a new shell and putting 1 electron in that first shell. All right, beryllium. So it's atomic number 4, so there's 4 protons. Mass is 9, I think, so it should be 5 neutrons. Okay, what am I going to draw? Yeah, 2 shells. First shell gets how many? 2. Right, so every element after hydrogen is going to have that first shell with 2 in it, right? And it's never going to have more. The first shell's done. We're just always drawing it in there. How many in the second shell? 2, because it's the second element in the second row, so it gets 2 in the second shell. Let's do boron.
Wait, why? So why lithium only get 1?
Because it's the first element in that row.
Oh, okay.
The third element in the second row is boron. 5 protons, 6 neutrons. So it's going to get 2 in the first shell, like they all do. And then the second shell's going to get how many? And if you're ever not sure, all we're doing is this. Yeah, it's going to be 3, right? 1, 2, 3. It's going to have 3 electrons in the second shell. We're going to put 1 more here. All right, carbon. 6 protons, 6 neutrons, that should be a plus sign. 6 protons, 6 neutrons. 2 in the first shell. How many in the second? 4. We're just adding 1 more, right? Every time we go along to the next higher element, we're just adding an electron. And for today, this rule here, rule number 2, is true up to atomic number 20. After calcium, the rules change, but we won't deal with anything higher than that today. So everything I've told you here is true up till calcium. All right, can I erase this? Everybody got this? Okay. I said the rules that I told you today are true up till atomic number 20. After calcium, the rules change a little bit, and I'll tell you about that on Monday. All right, let's do, we did carbon. Should I do all 8 in this row, or are we good? Should I just do neon? That's the last one in the row. Okay. Let's do neon. Okay, 10 protons. What's the mass of neon? Is it 20? So 10 neutrons. Okay, first shell gets 2. We know that. Nothing changes there. How many in the second shell?
8.
Yeah, you just count across the row. 1, 2, 3, 4, 5, 6, 7, 8. It's the 8th one. It gets 8 in the second shell. This doesn't have to be perfect. Just, space them out. There we go. Okay. Now we're going to start third row. That's sodium. 11 protons, 12 neutrons. How many shells? 3, because we're in the third row on the periodic table. First 2 shells are going to stay the same. Whatever we had for the last one in the last thing, then we're going to stay with that. So 2 in the first shell, 8 in the second shell. And then how many in the third shell? 1, because it's the first row, first element in the third row. So just put that 1 electron wherever you want. Magnesium's going to have 2 in the third shell. Aluminum's going to have 3 in the third shell. Silicon's going to have 4, up till argon, which is going to have 8 in the third shell. You want me to draw any more? You got this? All right, good. What you're going to do today, answer the first 2 questions, and then on the back, this is a mini periodic table. If you imagine, if there were only 18 elements, this stuff at the bottom didn't exist, we would just take these 2 and put them next to these 2. Beryllium would be next to boron, magnesium would be next to aluminum. That's how the periodic table would look. So that's what I drew for you here. And so as you go along, you just remember 1 electron in the second shell, 2 in the second shell, 3 in the second shell, so you can follow the table. And then, like I said, we'll talk about the higher numbers on Monday. 1, 2, 3, 4, 5, 6, 5. All right, Michael, this is your job today.
Did I do that last day? Where's your Did you do that? I'm trying to.
Yes, I am. Got a problem?
Yep.